To fully understand what gateway load balancing protocol is, we have to remind ourselves how HSRP works. HSRP will have an active router, and that active router will be responsible for forwarding the traffic from those users within that subnet. It will be responsible for handing out the MAC address for the virtual IP address as well. The standby router is not forwarding traffic at all. It is standing by, waiting for that active device to fail. So even though we have multiple default gateways, only one of them can be used at any given time. If we want to perform load balancing, well, in reality, it's called load sharing. So if we want to perform load sharing, we can do so by creating multiple HSRP groups, and each of those groups are responsible for a completely different subnet, meaning a completely different VLAN, and it requires a lot of work on our parts as administrators to make it all work. We're going to have to line it up with spanning tree protocol as well. However, with GLBP, we can have every single router within that group forwarding traffic by default. We do not have to have multiple groups. We can load balance traffic, truly load balance traffic within that single subnet. With HSRP, we were load balancing for different subnets. The traffic for one subnet went this way. The traffic for another subnet went this way. Well, with GLBP, all the traffic for an individual subnet can be load balanced. It can use different default gateways. So it's automatic. We do not have to do anything after the fact. We set it up, it figures out the best way to do it, and it does it itself. So it's true load sharing. I would say it's true load balancing in this case. With a single group, very little administrative overhead. Let me paint you a picture. I'm not an artist, but I will do my best. What do we have here? Well, I'm attempting to draw some type of topology and connect up all of our devices. All right, nothing too fancy. May look a little crazy, but what I'm trying to point out to you is that we have 4 devices at the distribution layer that could all be utilized as a default gateway for the particular subnet. So we're dealing with just one subnet here, one VLAN. Let's say the subnet we're working with in this example is 10.1.1.0/24. So all of these devices, all these end stations that we see here, they're all in the same subnet. The interfaces on these multi-layer switches, all in the exact same subnet. So with that in mind, how does HSRP work? HSRP says one of these will be responsible for forwarding the traffic for every single client. Whereas with GLBP, we can have all 4 of them forwarding traffic for the clients within this subnet. That's a big difference. Here's how this is accomplished. There will be an AVG, active virtual gateway, that is elected for the group. And this AVG would be similar to a card dealer in a card game. It is handing out the cards. Well, in this case, the AVG is handing out what? Well, it is handing out the MAC addresses that will be used by the clients. So its first job is to identify who the virtual forwarders will be for the group. So in this example, we end up with 1 active virtual forwarder, 2 active virtual forwarders, 3, and 4. So you have a total of 4 active virtual forwarders. So the AVG is going to distribute 4 different MAC addresses for each and every single one of these AVFs. It will also be responsible now for answering the ARP requests from the clients. So a client states, I need to get to 10.1.1.1, which is the virtual IP address that is being used for this GLBP group. It's the default gateway IP address that every single client's configured with. And the AVG says, use this MAC address. But it doesn't respond with the same MAC address for every single client. It can respond with these 4 different MAC addresses that are associated with the AVFs now. So one client sends an ARP request, the AVG says, use this MAC address. Another client sends an ARP request, the AVG says, use this other MAC address. And this is how we are going to achieve the load balancing within the subnet. Because now each client is getting a different MAC address returned to them. And as a result, that client's frame is being specifically addressed to that device that owns the virtual MAC address. So now the traffic flow from each client is going to go to the respective AVF that they have been told to utilize as their default gateway based on these virtual MAC addresses.